Section 5.2, problem number 6. Sociologists say that 85% of married women claim that their husband's mother is the biggest bone of contention in their marriages. Sex and money are lower rated areas of contention. All right. Suppose that 6 married women are having coffee one morning. All right, so N is equal to 6. Let me write that down. N is 6. Find the following probabilities. All right, so for part A, we want this. What is the probability that all dislike mother-in-law? Okay, just all dislike. Now, what we know is that 85% of married women claim their husband's mother, their mother-in-law, is the biggest bone of contention. So we'll say that that is disliking. So we'll say then that the probability of success is 0.85. All right, so what's the probability that they all dislike? So this is going to be the probability that X, the number of successes, is equal to, what do we have, 6? What's the probability we get all 6? We have a formula for this. We could do it by pencil. The formula says the probability that X, the number of successes, is R, 6 for us. N choose R times P to the R, Q to the N minus R. N is the number of trials. We have 6. R is the number of successes that you want. We have 6. P is the probability of success on a single trial. We have 0.85, and we want 6 successes. Q is the probability of failure, which is 0.15, and we want no successes. We could do it by pencil, but let's get used to using our calculator. So on our calculator, what we're going to choose is second, VARS. Have to find those keys, and this is where distribution is. Scroll down to item A. This is binom PDF, and we're using PDF. If you go to B, you get a C. C is if you have a collection of numbers here. We have only one number. If you have a collection, you would use CDF. But since we have only one, we're going to use PDF. So you go down to A, binom PDF, select A. What you get are trials. Now for trials, we have 6. Then you get P. What's the probability of success on a single trial? That is 0.85, so put an 85 in there. The X value, okay, that's going to be 6 because we want 6 successes. And then go down and paste. You press enter, and then what comes up is, you can't read the whole thing because it's cut off, but I can read this part, PDF, and then it says, okay, 6 trials, probability of success on a single trial is 0.85. I want 6 successes. Press enter, and what comes up is 0.377149, ... But we are supposed to round to 3 decimal places, so 1, 2, 3, that's a 1, so I'll drop it. So how about 0.377? So I will list that up here at the top on the left, 0.377. So if this 85% really is true, and there's 6 married women having coffee, how many of them, what's the probability that all 6 of them dislike their mother-in-law? That's about 38% chance. Now part B says, what's the probability that none of them, right? None of them. So here's B. What is the probability that we want none? Well, that means the probability that X is 0. Now, here's what we could do. We could do all this business all over again. But the last thing that you have in your calculator is this. This is the last thing that you actually put in. Now, try this. You can put it in all over again, or you can try this. Press the second key, and then down at the very bottom, press the enter key. Now, right above the enter key, it says entry. That will paste in the last thing that you typed in. So press second, enter. Now, what comes in is this. Now, that's not what we want. We want the 6, the 8.5, but we don't want a 6 here. We want 0 successes. So just run your cursor over to the 6. Get your cursor over to the 6 with your arrow key and just type 0. Now press enter again. Okay, now when I do that, here's what I'm getting. I get 1.13. Now I know something's up. That's a probability. It can't be more than 1. So I know what's going to happen. I'm going to get an E out here, -5. Now that's scientific notation for this. 1.13 times 10 to the -5. Now, scientific notation just moves decimal points around. To get that decimal point there, we must have moved it 5 places to the right. Negative tells me I moved it to the right. So to get it out, move it 5 places to the left. So there's 1. I'm going to need 4 zeros. So how about point? 1, 2, 3, 4, and then 1, 1, 3. But now we're supposed to round to 3 decimal places. So what's the probability that in a group of 6, none of them dislike their mother-in-law? That's going to be 0. So we will put a 0 up in here. Now here's part C. What is the probability of at least 4 dislike? Okay, at least 4 dislike. Now, as soon as I see that at least, we've done this before, right? I'm thinking, okay, well, how do you get at least 4? X could be, now it's at least, so 4 is included. It could be 4 or 5 or 6. Right, now the calculator doesn't really work this way. The calculator works so that it starts at 0 and comes up. So what I'm going to do is I'm going to think opposite. Okay, if I can spell it, think opposite. And the opposite of this would be what? That x is equal to 0, 1, 2, 3. All right, but as soon as I say think opposite, I need the 1 minus. So 1 minus. Now, let's go get binom CDF because I have a collection, right? There's a collection. So go get binom CDF. All right, so that's where? That's under B, I think it is. So what do? It's second, VARS. Scroll down to B, select binom CDF, but you have to put the 1 minus in first, right? So 1 minus, then go get binom CDF. And then trials, that's probably already in there from the last problem. So trials is 6. P, probability of success on a single trial, 0.85. And now the X value is the number that we have right here. That's the last number in our collection. That's the way the calculator is written. So we're going to put in a 6 and then paste. Well, I almost got that. Did you catch it? Our X value is not a 6. That's why I write it over here. The X value is a 3. I looked in the wrong place. The X value is a 3, so we need a 3 there. That makes a big difference. All right, now I'll paste, and then I'll compute, and I'm getting this, 0.95266. If I round off the 3 places, I'm going to get 0.953. And I will put that up here, 0.953. Let's finish it off here with part D. Part D says, what's the probability of getting no more than 3? All right, well, how do you get no more than 3? I think we can do this one directly. This is going to be what? X is, all right, no more than 3. You could get 0 or 1 or 2. You could get 3, right? I just don't want any more than 3. So no more than 3. Oh, look at this now. This is typical in textbooks. You see what we have here? 0, 1, 2, and 3. You see what we did over here? All right, that was the opposite, but we did 1 minus. So if you go back up to what we just did, you can probably run it from there. Get rid of the 1 minus. Or just do it again. Let's just do it again. All right, so what I'm going to do is I'm going to go to second, VARS, and then I'm going to scroll down to B because I have a collection, binom CDF, trials, 6. P-value, probability of success on a single trial, 0.85. I'll get this one right this time. The X value, that's 3. That's the last number in my collection. And paste. And then calculate. Or I just actually calculate, just press enter. And I'm getting 0.04733. So 047. All right, it's 0.047. And if I look at what I have here, the 047 and this 953, they add up pretty close to 1 because they're opposite events. So I'm going to claim this is 0.047. And I think that finishes section 5.2.